Welcome to the math dimension, young explorers. I'm your guide to everything 3D. Today, we're not just looking at pictures. We're training our brains to see the world like a geometric superhero. We're starting Module 3, 3D shapes. Think about it. Everything you touch, from your cereal box to your favorite ball, is 3D. It has length, width, and depth. It's chunky, it's funky, and it's full of secrets we're about to uncover. Are you ready to level up your brain? Let's dive in. First stop on our adventure, the quadrilateral prism. Sounds fancy, right? But wait, don't let the big words scare you. Look at this shape. It's basically a box. But how do we understand it? Look at the top and the bottom. Those are the bases, like the crusts on a sandwich. There are two bases. Now imagine walking around the middle. Those are the lateral faces. There are 4 of them. So, the total number of faces is 2 plus 4, which is 6. Whenever you see a shape, ask yourself, where's the top, where's the bottom, and what's connecting them? That's the way of the math master. Now, compare that box to this pointy fellow, the quadrilateral pyramid. Here's a thinking challenge. Does it have a sandwich top and bottom? Nope. It has one base sitting on the floor, and everything else meets at a single point at the top. It's like a math tent. It has one base and 4 triangles reaching up as lateral faces. That makes 5 faces in total. See the difference? Prisms have 2 ends, pyramids have 1 end and a point. Keep that in your brain pocket. It's a game changer. Time to be a detective. Look at the line where 2 faces meet. We call that an edge. It's the sharp part. If you were a tiny ant crawling on a cube, the edges would be the paths you walk on to get from one side to another. Look at the prism, the pyramid, and even that pentagonal guy in the middle. They all have edges. When you see a 3D object, try to trace the lines with your eyes. That line is where the magic, the faces, connect. Let's practice counting like a pro. How many edges does a triangular prism have? If you just point and count randomly, you'll get lost. Here's the trick. Count the top triangle, 1, 2, 3. Now count the bottom triangle, 4, 5, 6. Finally, count the lines standing up like pillars, 7, 8, 9. 9 edges in total. Always count in groups, top, bottom, and sides. It's the secret sauce to never making a mistake. Okay, over to you. Use our top-bottom sides trick. Look at shape 1, the pentagonal pyramid. It has 5 edges on the base and 5 lines meeting at the top. That's 10 edges. Now look at the cube. 4 on top, 4 on the bottom, and 4 in the middle. 12 edges. Did you beat the shape? If you did, give yourself a high five. If not, just remember, groups are your best friends in math. What about the corners? In math, we call a corner where 3 or more edges meet a vertex. If there's more than one, they're vertices. Think of them as the dots in a connect the dots puzzle. Look at the red dots on the shapes. That's where all the edges come together for a big meeting. When you look at a building or a piece of furniture, try to spot the vertices. They're the anchors of the 3D world. Let's count vertices on our triangular prism. Use the same grouping trick. How many corners on the top triangle? 3. How many on the bottom? 3. 3 plus 3 equals 6. 6 vertices. See? By breaking it down into top and bottom, you've made a complex shape super simple. You're not just counting, you're analyzing. You're basically a math scientist now. Time for a lightning round. Shape A is a pyramid. 1, 2, 3 on the base, and 1 at the top. 4 vertices. Shape B is a cuboid. 4 on top, 4 on the bottom. 8 vertices. It's like a pattern, right? Once you see the pattern, you can't unsee it. That's the beauty of geometry. It's like a puzzle that always makes sense once you know the rules. You've made it through the first level. Let's recap. Faces are the flat parts, edges are the sharp lines, and vertices are the corners. We saw a pentagonal prism with 15 edges and 10 vertices. Don't let it intimidate you, just count the groups. And our pyramid friend with 8 edges and 5 vertices. You've got the way of thinking now. In the next video, we're going even deeper into cubes and cuboids. They're everywhere. See you in part 2, Math Heroes. Welcome back, Math Heroes. Did you have sweet dreams about vertices and edges? I hope so. Today, we're zooming in on the most famous members of the 3D family, cubes and cuboids. Look at these shapes on the screen. Our friend here is asking a great question. What type of prism do they belong to? Well, spoiler alert, they're all quadrilateral prisms. That means they have four-sided bases. But why do some look so perfect, and others look like they've been stretched? Let's find out. In math, we love to put things in boxes, literally. Look at these shapes. We can divide them into two groups. In Group A, we have the cubes. They're like the perfectly balanced gymnasts of the math world. In Group B, we have the cuboids. They're like the tall, lanky cousins. But what's the actual difference? Is it just their height? Nope, it's all about their faces. Let's look closer at their skin. Their surfaces. Check out this cube. Let's peel it like an orange. Look at face number 1, a square. Face number 2, also a square. 3, 4, 5, 6, they're all squares. And not just any squares, they're identical. It's like a family of sextuplets. Every single side is exactly the same size. That's the way of the cube. It's perfectly fair. No face gets more space than the others. It's the most democratic shape in existence. So, here's the masterclass definition. A cube is a special type of quadrilateral prism. It has exactly 6 faces, and every single one is a square. If you see a shape and even one face is a rectangle, it's kicked out of the cube club. Sorry, rules are rules. To be a cube, you have to be square all the way around. It's hip to be square, right? Our bird friend here totally agrees. Now, let's meet the cuboid. This guy is a bit more flexible. Look at this one. It has 3 pairs of identical faces. But look at the shape. They're rectangles. It's like a cube that went to the gym and got stretched out. Each face is a rectangle, and they come in matching pairs. Top matches bottom, front matches back, and left matches right. It's like a well-organized closet. If all faces are rectangles, you've definitely found a cuboid. But wait, there's a plot twist. Look at this cuboid. It has 3 pairs of identical faces too, but look at the ends. They're squares, and the middle parts are rectangles. Does that make it a cube? Nope. Remember the cube club rules? All faces must be squares. Since this guy has 4 rectangles and only 2 squares, it's still a cuboid. It's like a hybrid shape. 2 squares plus 4 rectangles equals one very cool cuboid. Don't let the squares fool you. Let's recap the cuboid rules. A cuboid is a quadrilateral prism with 6 faces. The rule is, each face can be either a square or a rectangle. It's the inclusive cousin of the cube. Most of the boxes you see in real life, cereal boxes, tissue boxes, shoe boxes, are cuboids. They're the workhorses of the 3D world. They might not be as perfect as cubes, but they sure are useful. Final challenge for episode 2. Look at these 4 shapes. Can you spot the cubes? Use your thinking eyes. Shape 1. Looks a bit tilted, but are all faces squares? Yes, that's a cube. Shape 2. Definitely a rectangle in there. You're out. Shape 3. Too long. Bye-bye. Shape 4. Perfectly square all around. Yes. We have 2 cubes hiding in plain sight. Did you find them? Great job. You've mastered the world of cubes and cuboids. See you in part 3 for some unfolding action. Welcome back, Geometry Explorers. Today we're doing some math magic. We're going to turn 2D paper into 3D objects. Look at this pattern on the screen. It's 6 identical squares connected in a cross shape. If you fold them up, abracadabra, it's a cube. In math, we call this flat pattern a net. It's like the blueprint for a building, but for a box. Think of it as the cube's flattened out skin. Ready to find more? Let's go. Time for an activity. Imagine you're in a group of 4. You have 6 identical square cardboards. Your mission, should you choose to accept it, and you must, because it's math class, is to arrange these squares in different ways. But here's the rule: they must be connected. No floating squares allowed. Use your adhesive tape and your imagination. We're on a hunt for all the different ways we can lay out a cube. How do you know if your pattern is a winner? You give it the fold test. If you fold it up and it makes a perfect cube without any sides overlapping or leaving gaps, then congratulations, you've found a net. If it fails, don't worry. That's just part of the thinking process. Separate the squares and try a different layout. In math, wrong answers are just steps on the ladder to the right one. Check out this grid. Look at all these different patterns. Some look like T's, some look like stairs, and some look like, well, weird geometric squiggles. But guess what? All of these can be folded into a cube. Can you believe it? There are actually 11 different nets for a cube in total. Try to trace the folding in your mind. Imagine which square becomes the top and which becomes the bottom. It's like a mental workout for your spatial reasoning muscles. Now, let's step up the difficulty. What about our friend the cuboid? Remember, cuboids have pairs of matching rectangles. So, when you make a net for a cuboid, you can't just use 6 identical squares. You need 6 rectangular cardboards that match in pairs. It's like building a puzzle where the pieces have to be in the right spots to match up when they fold. This is where your sandwich thinking from episode 1 really pays off. When you fold a cuboid net, the matching faces need to end up opposite each other. If you have 2 big rectangles next to each other in the net, they might overlap when you fold. So, the way of thinking here is to space out your pairs. It's like a strategic game of chess. If you can form a cuboid, circle that pattern on your grid. It's a rare and beautiful thing. Look at the patterns we've created. Some of these work, and some are just pretty paper shapes. In math, being able to visualize the fold is a superpower. You've now mastered the unfolding truth of cubes and cuboids. Give your brain a rest, math heroes. In the next video, we're going even deeper into solve some serious shape mysteries. See you in episode 4. Welcome to episode 4, Math Detectives. Today, we're solving a major geometric mystery. Look at this cube. It has different colors on each face. Now, look at that flat net next to it. If we fold it up, which color goes where? It's like a high-stakes puzzle. We're going to learn 2 top-secret methods to crack this code. Get your thinking caps on. It's deduction time. Method number 1, the hands-on approach. If your brain is feeling a bit tired, just use your hands. Cut out the net, fold it into a cube, and color it in while looking at the pictures. Then, this is the cool part. Unfold it. Boom. You have the perfect map of where the colors live. It's like unfolding a secret treasure map. This works every time, but can we do it without the scissors? Let's see. Method number 2 is for the true math ninjas, pure deduction. First, pick a starting face on the net and color it. We'll start with pink. Now, instead of folding paper, we're going to fold our minds. Imagine that pink face is the front of the cube. What's next to it? What's above it? We're going to build the cube in our imagination, one face at a time. Look at figure 1. If the pink face is the front and the yellow face is the top, where does yellow go on the net? It has to be connected to the top edge of the pink face. And the blue face, it's on the right side of pink. So we find the right side on the net and color it blue. We're connecting the dots, one step closer to solving the mystery. Now look at figure 2. The cube has turned. Now blue is the front and yellow is still the top. Wait, what's that orange face on the right? If blue is the front, orange must be the next face over on the net. We're filling in the blanks like a geometry crossword puzzle. Notice how the faces stay in the same neighborhood even when the cube moves. That's the secret. Final boss time for method 2. Look at figure 3. Purple is on the bottom and green is on the back. Can you place them on the net? Remember, the bottom is opposite the top and the back is opposite the front. If yellow is top, purple goes down there. If pink is front, green goes over there. And we did it. No scissors needed, just pure brain power. You guys are amazing. Ready for a real challenge? No colors this time, just symbols. We have a circle, a triangle, and some hashtags. If you look at the 3 views, can you figure out what goes on the empty face of that 4th cube? Hint: look at what's opposite the hashtags. This is where your deduction skills really shine. Take a second. Did you get the pink plus sign? Yes. You're a shape-solving genius. Let's revisit our net friends. Out of these 4 patterns, which ones are true cube nets? Use your mental folding. Pattern 1, overlaps. No good. Pattern 2, wait, that's our old friend the cross. That's a winner. Pattern 3, a T-shape? Yes, that works too. Pattern 4, looks like a staircase. And yes, it folds up perfectly. 2 out of 4 ain't bad, but finding 3 is better. Now for the cuboids. Remember the sandwich rule? You need 3 pairs of matching rectangles. Look at the top left. Those long rectangles will match up perfectly. Top right? Looks suspicious. Bottom right. Those squares are in the right spots to be the ends of the box. We have 2 valid cuboid nets here. It's all about checking for those matching pairs. Last puzzle of the day. We have 5 squares on a grid. We need 1 more to make a cube net. Where would you put it? There are actually 3 right answers. You could put it at the top, in the middle, or at the bottom. Each spot creates a different valid net. It's like building your own math adventure. That's it for episode 4. Next time, we're building shapes with sticks and clay. See you then. Welcome to our 3D workshop, Math Engineers. Today, we're not just looking at boxes. We're building them from the inside out. Look at these cool structures. Besides paper nets, we can use clay pieces and sticks to make frameworks. It's like building a skeleton for our geometric friends. It's hands-on, it's fun, and it reveals the secret structure of every shape. Ready to get building? Let's go. Check out this building plan. We start with a single stick and a clay ball. Then we build a square base. Then add the vertical pillars. And finally, put the roof on. Look at how the cube and cuboid frameworks grow piece by piece. It's like watching a skyscraper go up. Pay close attention to how many clay balls and how many sticks we use for each shape. Every single piece has a special job to do. Now, let's look at our construction data. For a cube, we used 8 clay pieces and 12 sticks. And for a cuboid, wait a minute, it's also 8 clay pieces and 12 sticks. Why do you think 2 different looking shapes use the exact same number of parts? This is a major math mystery. Can you see the connection to what we learned about edges and vertices? I bet you can. Here's the masterclass reveal. The number of clay pieces is exactly the number of vertices, and the number of sticks is exactly the number of edges. The balls are the corners and the sticks are the lines. But there's a catch. For a cube, all 12 sticks must be the same length. For a cuboid, you need sets of different lengths. It's like a building code. If you use the wrong sticks, your building won't be a cube. Final challenge. Look at these 2 sets of building materials. Which one can form a cube? Set A has sticks of different lengths. Set B has 12 sticks that are all identical. Remember the cube rule. Every edge must be the same. So the winner is Set B. You've officially graduated from our 3D construction school. Great job. See you in part 6, where we'll discover the secrets of the curvy cylinder. Welcome back, math legends. Today, we're meeting the curvy cousin of the 3D family, the cylinder. Look at these shapes. Notice something different? No sharp corners. A cylinder has 2 identical circular bases and 1 curved surface. It's like a soup can, a rolling pin, or a giant battery. But how does something so round turn into a flat net? That's the secret we're about to uncover. Imagine you have a cylindrical paper box. If you take some safety scissors and cut it along the edges, look what happens. The curved surface rolls out into a giant rectangle, and the 2 circular bases stay attached. So, the net of a cylinder is made up of 2 identical circles and 1 big rectangle. It's like a math wrapper. Whenever you see a rectangle with 2 circles, your brain should scream, "That's a cylinder waiting to be born." Time for some detective work. Look at net A. It has a rectangle and two circles. But wait, look where the circle on the left is positioned. If you try to fold this up, that circle won't meet the other side to form a base. It's in the wrong neighborhood. So net A is a big no. Remember, position is everything in the world of nets. Now, look at net B. One circle on top, one circle on the bottom, right in the middle of the rectangle. When you roll that rectangle up, the circles will fold perfectly onto the ends. It's a match made in math heaven. This is the classic cylinder net. If you see this pattern, give it a thumbs up. It's ready to roll. What about net C? Both circles are on the same side of the rectangle. If you fold this up, you'll have two bottoms and no top. Or two tops and no bottom. Either way, your soup will spill everywhere. This is a classic base blunder. To be a cylinder, you need a base at each end. Net C is a definite no-go. Last one. Net D has the circles on the short ends of the rectangle. But wait, if you roll it that way, the circles won't fit the circumference. They are positioned in a way that they simply cannot be the bases of the cylinder. It's like trying to wear your shoes on your hands. It just doesn't fit. So, net D is our final no. Only net B takes the crown. You've mastered the cylinder, heroes. See you in our final episode for the integrated exercise party. Welcome, Geometry Legends, to the grand finale of our 3D Shapes adventure. You've braved the world of prisms, survived the mystery of nets, and even built skeletons in the math workshop. Now it's time for the ultimate test. We're entering the integrated exercise party. Look at these shapes on slide 47. We have a cuboid, a pyramid, and a prism. Use your top-bottom sides trick to count those edges and vertices. 12 edges and 8 vertices for the box, 12 and 7 for the pyramid, and 18 and 12 for the hexagonal prism. You're already crushing it. Before we dive deeper, let's refresh our club rules. For the cube club, 6 faces, and they must all be identical squares. No exceptions. For the cuboid club, 6 faces, but you can have squares or rectangles. Just remember to look for those matching pairs. If you know these rules, you can identify any box in the world. You're not just looking, you're analyzing like a pro. Time for a net marathon. Look at these 4 patterns. Which ones can fold into a cuboid? Remember the fold test in your mind. Imagine the rectangles folding up to meet each other. Pattern 1, overlaps. Pattern 2, that's a winner. Pattern 3, also works. Pattern 4, wait, that one's just a long line of paper. We have 2 perfect cuboid nets here. Did your mental folding match mine? I knew it would. Now for the letter challenge. Patterns R through W. This is where we separate the amateurs from the masters. R folds into a cube. T is another cube net. And W makes a cuboid. But wait, look at V. 2 circles and a rectangle? That's our curvy friend, the cylinder. Being able to identify these flat patterns is a superpower that helps you understand how everything from cereal boxes to battery packs is made. Can you draw your own? Look at this 2cm box. To draw its net, we need to lay out all 6 faces on the grid. Start with the base, then add the 4 walls, and finally the lid. It's like drawing a map of a house before you build it. Notice how the matching faces are spaced out? That's the secret to a successful fold. You're not just a mathematician now, you're a geometric artist. Let's do a lightning recap of everything we've learned. Edges are lines, vertices are corners, cubes are all squares, cuboids are a mix. A cube net has 6 squares, a cylinder net has 2 circles and a rectangle. If you can remember these simple truths, you've mastered the 3D world. Take a deep breath and smell that geometry knowledge. It's glorious, isn't it? Math even helps us celebrate. Bella and Jerry are using edges and vertices to make tree decorations. 12 strings for the cube, 8 beads for the vertices. And look at that gift wrapping. To wrap an 8cm cube perfectly, you need 6 squares of 64 square centimeters each. No wasted paper here. You're basically a Christmas math elf, saving the holidays one shape at a time. Last stop. Jerry's back in the workshop building a cuboid and a triangular prism. Look at those skeletons. They reveal the true nature of the shapes. And with that, our 3D adventure is complete. You've trained your brain to think in 3 dimensions. You've mastered the way of thinking that will stay with you forever. Congratulations, geometry superstars. Keep thinking, keep building, and stay curious. Class dismissed.